realized that it's a time to bring in the new innovation. And that's why I formed another company called OptraSCAN since last 5 years with lots of innovation we are doing. And that's where we look at digital pathology as 2.0, which is the future compared to what happened over the last 15 to 18 years in the industry. We were the first company in 2002 competing with Apperio, and both these companies change the complete scenario of pathology into digital pathology. But now it's the time to make another wave of change, and that's why we are back into digital pathology through OptraSCAN, and that's where it's digital pathology 2.0. But before we go to digital pathology 2.0, let's look at the pain points of digital pathology 1.0. Lots of countries have already implemented digital pathology based on their capacities, but one of the significant challenge has been the cost, and that is why low adoption. People were using the microscopes in the older days. It's almost 200-year-old invention, which is a microscope, but then that is costing only $5,000. And there is an automated microscope costing $30,000. And then people started bringing whole slide imaging devices for $150,000. So look at the transformation price from $5,000 to almost $150,000. And that is where the biggest challenge that happened in the pathology industry, when it's a small to mid-sized players, that they just couldn't afford it. And that's why the adoption of the digital pathology is still very low, because most of the vendors are at that price point of $150,000 and above. The second challenge that digital pathology saw over the last 15, 18 years is in terms of usage of cloud. Now, cloud is becoming an essential component for the storage of the data. But then with the pathology tissue or the cell images, with almost a gigabyte of a data per glass slide when converted into an image. But then, today when we are seeing many of the speakers are having the challenge in connecting to this conference. And that's because there is a bigger bottleneck, not in the scanning devices, but in the infrastructure itself. And that is where you can have a very fast scanner, but if you do not have a good internet bandwidth, how can you get into digital pathology? Was the second bottleneck that industry observed over the last few years. The third market pain point is in terms of the image quality. No scanner is able to produce an image with 100% quality assurance because the slide is different, because the staining is changing, because there is no consistency in the way the slide is prepared, because the cover slip may not be properly stuck onto the slide, and lots of challenges. But at the same point of time, what happens to the cytological images where the cell itself are distributed in an uneven fashion, because of which the focus changes. And that is why Z stacking or taking the images at different Z levels of the slide are not enough. So you require a smarter mechanism to collect the data and then put it back into a digital format. And that is where the third bottleneck started popping up very recently, when people wanted to use image quality as one such parameter to ensure that every image that comes out of the scanner is scanned properly, and without a human intervention, can scanner understand that my image is not proper, let me scan it again. So how to make the scanner intelligent became the third bottleneck in the industry. And then the fourth one is in terms of image analysis. Many of the users like pathologists, they say that, hey, why should I even scan image and look at it digitally when I can just look at it, using my own eyeballing techniques? So how can we replace an ability of a human to actually do the analysis in a more efficient way? But the challenge with the human is the repeatability, and also in terms of the consistency. That's where the software systems come into place. So that is where it is important that how can we avoid the delay that the software analysis can bring into the whole system when human himself or herself can do that. And that is the fourth pain point that is actually floating in the industry. And that is where OptraSCAN came to this market with a mission to bring in digital pathology 2.0. In terms of this, the first offerings that we bring to the market is called as Composite Imaging. That how can we build a good image quality at an affordable cost? Can there be a scanning cost of not more than $1 per slide? And how can I do it for my different capacities and different loading that is required into the scanning. Could it be, as small as 15 slides to 80 slides to maybe 100 plus slides, or maybe 300 plus slides, or even high production 400 plus slides, or even can I have the continuous slide loading? And that is where OptraSCAN has built an ability with artificial intelligence to build a composite image. A composite image is a mechanism where each pixel in that image is in perfect focus. You do not need to do a Z stacking to do that, but the computer and also the scanner, they themselves can do it for you. So this is the composite imaging technique that we brought in into our scanning systems. We have the worldwide patents on this now. And because of this scanner is making a significant bottleneck getting resolved, which is in terms of the good quality at an affordable price. And also has happened with another scanning system whose image quality score is shown as 7.87, but whereas OptraSCAN is consistently scoring almost 9.5 and above in terms of the scoring, because each scan that happens is verified by the scanner using the artificial intelligence before it is saying that, hey, the scan is over. And this is all happening at a fraction of a second. And that is where this is the smarter and also the quality way of managing your slide images. The second feature is, how do I solve a challenge of storing into the cloud? Because cloud is a necessity. We need to have all our image data to be moved into the cloud. But for doing that, if I start storing my data locally, then each of my glass slide, when it converted into an image, becomes almost a gigabyte of data. How do I transfer that data on my poor bandwidth in many of the countries to the cloud? Because then more than scanning, uploading takes a significant long time. So we resolved and we actually came up with a solution called as a stream as it scans. So the scanner is now a very smart device that can not only create a very high quality image, but can also stream into the cloud as it scans. And then our software inside the cloud converts that into a whole slide image. And that is where you see many of the countries which are having the challenges of the poor bandwidth, including the emerging markets in Asia, in Africa, South America, that started using our systems because it's cost effective, it's high quality, as well as it can streams into the cloud as it scans. And that is where AI-enabled smart cloud upload becomes our second offerings in this industry of digital pathology to convert into 2.0. And then our third offering is in terms of when you analyze while it is scanning. The analysis, Google Map, you do not want to spend time in analyzing it. It should just analyze, because the whole purpose of my scanning is to analyze. Otherwise, why do I scan it other than the archival purposes? And that is where we build the third ability, where it says it analyzes as it scans. Our work is already published in Nature when it comes to analysis for the biomarkers, when it comes to analysis for the morphometry analysis. It could be for the prostate, it could be for the breast, it could be for the renal, and also for the fluorescence, taking care of the multiplexing. The systems are used in a significant way at the National Cancer Institute in United States. But let me summarize here, because now that the session is delayed, I'm just trying to save the time for the organizers. So this slide actually summarizes what we are building at OptraSCAN. We have the smart devices. Gone those days where it was talked about the scanners. Now it is the time to talk about the smart scanners, where it is already the artificial intelligence embedded into the scanners. It has the continual loading of slides without pausing the scanner. To prepare 1,000 slides and analyze it, maybe it's easy, but how to prepare those 1,000 slides? It's going to take many days for people to prepare those slides. And that is where it is important that the scanner should start scanning, not to wait for all 1,000 slides to be loaded, but as soon as you load even a single slide, it should start scanning. And that's why the time saving happens. So we have a continual slide loading ability, ranging from 15 slides to 80 slides to 160 slides to 320 slides to 480 slides, and all are available at a very cost-effective way. We have a patented composite imaging technique which ensures 99% of the in-focus slide images. You do not require to scan anything because it has an AI-enabled abilities to verify its own scanning quality and then rescan if required. It scans in less than 60 seconds at 40x. Because nobody now looks at 20x, right? Because you require higher magnifications. And that is where 75,000 pixels per inch, almost a quarter micron per pixel, is where we are actually giving the resolutions of all these scan data. And that is also happening in less than a minute. It has the digital zoom up to 100x. Is it scanning? It is storing directly into the cloud, or you also have an option to store locally. It has embedded analytics. You do not require additional analytics to be running on the top of it. And then all these devices are CE marked for the in vitro diagnostic use. And we offer for the both bright field as well as for the immunofluorescence. In the last 12 months that these products are in the market, we have sold more than 43 customers globally. We have 17 distributors, including Nikon, including Fujifilms, who are helping to distribute these devices globally. These customers like we have in UK, we have customers in Germany, we have lots of customers in India, in China, Japan, and then lot many here in United States. Our advisory team consists of the chairman of pathology from the 5 different institutions involving Stanford, UCSF, UCLA, Duke, as well as Yale. So OptraSCAN brings together all the components, all the pieces of the puzzle, but in a smarter way. We have the scanner, but it's a scanner 2.0. We have image management system integrated with most of the workflow softwares. We also have image analysis, batch processing, telepathology, remote interpretation, and this has the mobility interfaces. And then we also work with Salesforce for its cloud laboratory information management system. So this is in nutshell about OptraSCAN that we bring to the table, digital pathology 2.0. Thank you.